Okay, and I believe we're live.
Live. And do we want to start, Graham?
Yeah, for sure.
Saying a few words.
Hi, everyone. Welcome to the next installment of the TAC Young Members 101 Introduction to Tunneling webinar series. I'm very happy to present President of VMT, Mathias Knoll, to talk about the basics of TBM Guidance Systems. So, Mathias, why don't you introduce yourself and tell us about what you're talking about today, and move on with your presentation, please.
Yeah, thank you, Graham. Thank you also to Tech Young Members for giving me the opportunity to tell you a little bit more about TBM guidance and how the system's ensuring to mine properly from A to point B within several millimeters or sometimes centimeters. A few words about myself. So I'm working with VMT now for over 15 years. The VMT is celebrating actually this year 30 years. So for more than half of VMT's history, I'm part of it. And in 2011, I moved to the US and was basically asked to take care of VMT's business here in North America for a couple of years. Now it's 2024, so I'm entering my 13th year here. Obviously, I like it that much, and not thinking about going back to Germany yet. We will see. We will see how things go. Actually, I had also my first project in Canada in 2011. I still remember quite well, November 2011. It was a microtunnel near the airport. And from then on, we got more and more involved in the North American, especially also in the Canadian market. Started more with the microtunneling work, direct pipe, and obviously also now with all these major infrastructure projects across Canada, from east to west coast, from Toronto to Vancouver. We are also quite involved in these projects with our solutions. Not just with guidance systems, there's also other solutions on projects in Toronto, which I will mention a little bit later. And I always enjoy also the tech events in Toronto. I have to say, last year the conference was really nice, was really well, not just attended, also executed. So just also congratulations from my side. I'm looking forward also to Montreal this year, and then obviously at some point you have also the WTC coming to Canada. So for us and for the tunnelers, Canada, Toronto, quite the hotspot. So now a few words about VMT, give you a little bit idea of what VMT looks like in Germany. It's like halfway between Herrenknecht and Frankfurt Airport. So always feel free when you do a nice trip to Germany and you want to combine vacation and work. You can do a stop at the VMT office. We have always nice people there who show you the latest and greatest developments and solutions. And it's right next to the highway, so it's just perfect. Before you drive the 2 hours to Schwanau from Frankfurt Airport, do a little stop, have a snack at VMT, and have a chat with the people. For us, it's also important to have interaction. You know, you as your engineers are part of a contractor or a designer, or you work for university. So for us, it's also good to have a feedback and a direct conversation, because eventually we also, you know, don't develop the products or the solutions for us. We develop them for the actual tunneling world. So that's why we're also happy to have this open conversations with you. A little bit feedback. VMT founded in 1994. So this year we're going to celebrate the 30 years in summer. So maybe a good time you come in summer and come to the VMT party, 30 years party. We are obviously part of the Herrenknecht group. So that's why the majority of the Herrenknecht machines also are equipped with a VMT system. So there's also a strong relationship and cooperation between both companies. That also means communication and then integration of the solutions. Besides having a group of engineers and product management, which is mainly focused on tunneling, we also have a group that works actually in a portion that's called metrology, where we do very precise measurements for, like, for example, Airbus in Europe and other companies who require sub-millimeter accuracy. So very more accurate than what we normally need in the tunneling world. A little bit an idea about the map and where we are located. We have some permanent offices, obviously around the world, or local presence in parts. Obviously, South America, it's a little bit a blank spot in Africa. And what you can see here, we cover at least a lot of time zones, which makes it definitely easier for also remote support when clients need our help. And our office here is located on the West Coast. Strategically, I would say not the best solution when you think about communicating with Germany, but it's historically grown also because Herrenknecht office is also located here. Maybe at some point we're gonna have a representative in Toronto to make things a little bit easier for everyone. Also, for me, it's also important to mention a bit the people. So this is not the whole VMT group. We have obviously about 200 people, but the people who are located here in North America, and you maybe come across already, or you will see them or meet them. So these are my colleagues, my team. We still have, for sure, if there's a need for more people, we can get them from Europe, from other offices. But this is the permanent presence here with people in Canada or in the US located. I didn't find a picture for Klaus, so that's why I put this one in with the little Playmobil person. And a little bit history, milestones, projects. You might also see some of your Canada projects in here. I think most recent one, obviously Scarborough, bigger project right in front of, maybe right in your backyard in Toronto. Put it in there because of the size of the machine and the nature of the project. Yeah, and as I mentioned, started early in 1994. With the first projects, and obviously around the world, all these main infrastructure projects, the majority VMT was involved in it. What does VMT actually do? It's also important for me to share with you a little bit the portfolio, to have an understanding where we are involved and how. There's obviously, great, now this is not working anymore, this animation here. Worked before testing, great. Anyway, TBM guidance, and not just purely for guidance of big segmental lining machines, like I mentioned, the Scarborough machine or the Eglinton machines. No, you also have to consider smaller diameter tunnels, microtunnel. So there's also a lot of microtunneling work in Toronto, and we're talking in comparison, like a Scarborough 12-meter roughly ID versus 1200 millimeter, so 1.2 meter ID. So big variety in terms of tunneling, also tunneling methods that we are covering with our solution. So that also means not just TBM driven tunnels are equipped with VMT guidance system, for example, also for the conventional tunneling with road headers or excavators. We have proper solutions so that they also ensure they can cut a proper profile with the machines, so they don't over excavate and cut more material out, which results eventually also in more shotcrete, more cost, etc. And a vital part for the segmental lining projects obviously are also the precast segments. So in the production of the precast segments, that also requires a proper logistics, proper handling of these segments in terms of the storage, documentation about damages, and then always ensuring, you know, that this machine is probably equipped, or let's say you always ensure that it's always guaranteed that you deliver the segments in the right order to the machine. You can have a complex ring design or along the alignment, like for example, the LA Outfall project in the US, a variety of segments. So depending on the geology, there's a different kind of reinforcement. They have post-tension rings. So they also have to make sure at what time they have to set in what type of segments, because you mentioned the longer the tunnel gets and you set the wrong segments in, that means downtime on the machine because they have to send the segments back to the surface, send another train in, and this is also what you want to avoid. And we also know that on each job site, communication is the key. So how people communicate is essential, and these systems can at least contribute to the communication in terms of automating certain processes more. And that's a tendency that we all see where the industry is going, more automation systems, trying to take, I wouldn't say take away the work from the people, but definitely we're trying to minimize human error with these solutions, and eventually also going towards an automated TBM steering, automated mining, automated ring build. So that's definitely where the industry is going right now, and all these TBM manufacturers are working on, as well as their suppliers. And for the segments, one crucial thing is also the accuracy of the segments in terms of the geometrical accuracy. For sure, we're talking about concrete quality and so on, but that's also an essential part, that these segments have accuracy of sub-millimeter, because they're little puzzle pieces, jigsaw. You need to put them together and you want to make sure they fit nicely. So for this, we do very precise measurements with what's called a laser tracker, where we can go to the facility where they make the segments or where they have the molds. We measure them and compare them to the designs, make sure they're on tolerance. You want to make sure these segments are on the right shape before you send them into the machine. You don't want to be in trouble down there and figure out later on that you have problems with cracks on the segments because of bad geometry. And then for sure, the data from all these data sources go straight into a system, which is a cloud-based system, depending on what kind of project you have. You get all the TBM data, for example, easy accessible guidance system data in a cloud-based system, or from the precast segments, you can also receive these data in a cloud-based system. So here's the short description about it, what I just briefly explained, but normally there was an animation which should be working but didn't work. And what's also important for us when we consider with the guidance systems or with any other solution we provide, it's about the journey. It's not just about the destination. For sure, the goal is we need to arrive at the end at point B, but how do we get there? How do we improve our workflow? How do we reduce risk that people doing mistakes? How do we ensure that we detect problems early, right? So and this is also a part for us, how we can contribute to it as VMT. In terms of the guidance system itself and how they contribute, it's for sure precision, accuracy. That's also was written in the abstract to this presentation. Millimeter accuracy, but also I have to mention it's not just about the system itself, it's also about the people using it. So it means also people need to be educated, need to have the understanding for it, to use the tools properly. Guidance systems also contribute to the safety. If we're going offline in a tight curve and we have to steer back with an even more tighter curve, what would happen? We might have problems on the segments causing cracks. We have water inflow and so on. So also we have direct impact on the safety or indirect. And you also want to make sure that the systems are working efficiently for the job sites and they're not causing, let's say, delays in mining. You don't want to stop a machine because the guidance system is not working. So you also need to consider that the system is well integrated on a tunnel boring machine. And as I mentioned earlier, automation, innovation, the systems are evolving, the technology is evolving, the sensors we are using, which gives us new opportunities, but also us having these new opportunities with the systems eventually also allows like a machine manufacturer to have progress in their developments as well. This is actually a really nice animation, or right now I took a screenshot here, which gives you an idea about the mining cycle, which is part of the advance. The other part is ring build, not the downtime. We know we have downtime for certain reasons, planned downtime, unplanned downtime. But you can see in the mining cycle, obviously the guidance system here is contributing with giving a position of the machine, but there are other values also going into a guidance system. In terms of calculating the ring positions, you know, how a ring needs to be orientated with its keystone position to ensure that the ring is following the machine properly. Because eventually we all want to see a nice, clean tunnel with basically no damages. That's what we want to give as a contractor to an owner. Unfortunately, that's not always happening, but we need to see that we come at least close to this goal. When it comes to selecting a guidance system, and we are mainly focused now on the actual TBM tunnels. So overall, we need to see what kind of method do we have. Are we having a conventional tunneling method? Do we have a segmental line tunnel? Or do we have a hard rock tunnel with a gripper machine where there's no segmental lining? Or do we have pipe jacking? So this defines, first of all, the machine design can define what kinds of guidance system is being used. On the smaller tunnels, you also need to see what are my tolerances that I have, like on a micro tunnel, for example, that it decides if you just can go with a simple laser because it's a straight run, or if you need to supplement the system with additional sensors to make sure, because of the distance, that you can ensure to be within a few millimeters over, let's say, 1,000 meters of micro tunnel. And even ground conditions can affect the actual system. So not all systems are optical systems, which require line of sight. So the majority of the guidance systems use like total stations, but there's also called a gyro-based system. A gyro is more or less like a compass, electronic compass, and gives you a direction. And as this compass is traveling, we can calculate where the machine is going. But these gyroscopic systems are, let's say, very sensitive, can be the ground conditions. When the machine, for example, is drifting, then these gyro systems might not detect it. And then you see, when you do a survey check, deviations. When you think about drift, what it is actually, if you would place a compass on your desk, and you look at the direction where the compass is pointing at, and then you just slide it slightly left or right by, let's say, 3-4 centimeters, so a couple of inches, it would still point in the right direction. And that's the same for the gyro. Gyro would not detect this shift, and this can easily happen in very, very soft ground conditions. But at the end, it's not just the equipment. So that's really important also to say. You can have the best guidance system, but you also need the right people for it. You need to have the people who have the education, who have the understanding, who have the background of it. And we're seeing this more and more. There's a lack of experienced people also on the surveying side in tunneling. There's at the moment a lot of tunneling projects in North America, but unfortunately people are retiring, and there's not a lot of new generations coming. And we have seen also that the contractors didn't fill really the gap and have really foreseen the future in terms of bringing already a new generation early on board. Now they're having already people are phasing out, and all this knowledge is gone because there was no proper handover over, let's say, 5 to 10 years. And you're not born as a tunnel surveyor. Nobody's born. There's no education for it, that you can go to school, and there's nothing really that can give you all these tricks that you need other than the real world going out there. And some people can adapt themselves easier to the environment. We can also see that surveying in a tunnel is not always the nice tunnel like Alaskan viaduct. Like on the right hand side, you can see on the left hand side a 48-inch pipe, 1200 millimeters ID, wet, dirty. This is even almost still a clean one. I mean, I've seen some with bentonite. You came out. I personally went in many of these, and it's not always the best environment. It also means you're not always attracting the people. Also for us, important to see how can we automate stuff so that we don't even need to send people in there anymore. Because also we are facing the same problem like the contractors are. You know, we are not always finding the right people or keep these people happy. And obviously these tunnels, you're also not the tunnels where you want to work all your life. When we come back to the guidance system, really important is also as part of the achieving the accuracy of a system is also the surveying part, without going here into depth. But it's really important that the contractor who has either a subcontracted surveyor or their own surveying team really, understands what is needed, what are the potential costs. And as a surveyor, you're always on the bottom of the food chain too. So surveyor never gets really an attention until the machine breaks through. That's when you get the most attention, or when you go offline. But at the end, when it gets covering costs and how much contribute to survey, they always keep you really low on this. And that's very unfortunate, because we play a really essential part to it. Probably everybody's saying this who's contributing to a tunnel project, but eventually we should always keep in mind what are the risks of getting offline. What are the risks of having a tunnel where utilities are pretty close, existing gas lines, and there's a risk that you can mine into one of these. I don't know if you've seen the video of this drill that drilled into a tunnel in Turkey just recently, hit a subway tunnel. Obviously bad as-built, bad data, bad information, who knows, but also somehow related to survey. So always have an open eye, an open ear for your surveyors, and most of them know what they are doing. Most of them know what they need. And to achieve accuracy on longer tunnels, there's something called a gyro verification survey. There's companies who are offering these solutions. And this is not the guidance system. This is really surveying related. So also surveyors really need to come up with a concept how to transfer all their survey control from a portal or from a deep shaft or from the surface, first of all, into the bottom of a deep shaft and then transferred from there all the way to the front of the machine. Because each guidance system, it doesn't matter what guidance system it is, it needs independent checks, not just for your peace of mind. Also, each system goes over a distance, loses its accuracy because you're starting off some really good coordinates, but the coordinates that go into the system, and as the machine is moving forward, you generate maybe new coordinates for prisms out of a guidance system. They're losing their overall absolute accuracy. That means an independent survey check is needed to update these coordinates. Yeah, so that means you make traverse measurements, zigzag lines, depending on the alignment, depending on the diameter. So the surveyors also really need to get really creative with this, which also means for them, they come up with a concept at an early stage how they approach this tunnel. But now, finally, we start with the systems, guidance systems itself. Most of you probably have been on the machine already. If not, then this is maybe the first view on a system. Maybe even if you have been on a machine, there's so much going on, you never paid attention to the guidance system and the components, what is actually being used. So for these, let's say, the standard projects, which are segmental lining projects, doesn't matter if it's a metro, a CSO tunnel, a water tunnel, most of these systems are using total station-based systems. Total stations. So what you know from a surveyor, they're mounted on a bracket, sitting on the tunnel wall. Here, there's a wireless communication between the machine and the actual total station. So the operator who's controlling the machine needs to have a live position of the machine on a screen all the time, so that we can ensure that he's steering the machine properly. You know, he knows that he is approaching a curve. So that also means for him, approaching the curve means I need to start steering the machine more. It's like, you know, you drive your car on a highway, there's an exit. You see the exit sign, and you know it's maybe 100 meters. At some point, you need to start steering into the curve. That's the same for the operator. And something I want to mention too is, on a subway tunnel, it's typical when you go from a straight into a curve, you put a transition curve in it, which is called a spiral or clotoid. I'm not seeing this much on CSO tunnels, and I can only emphasize and also advise you when you work in a design team or contractor team, consider also these spirals for CSO tunnels, for example. I know the water doesn't care if it's flowing through a spiral or through a curve, but it makes the TBM operation easier. Think about having a CSO tunnel going from a straight into a 200-meter left turn. There's two risks. A, the operator is steering too late. What is going to happen? Now he has to oversteer and steer even more. This can cause problems on the back of your machine. And maybe your ring design cannot even follow, which can be quite critical. And B, it's simplifying overall the ring selection process and makes things definitely easier. A smoother transition from a tangent, a straight, into a curve by using a spiral is definitely helpful. So keep this in mind when you design one of the next projects, or you've already gotten a project and there's still time, have a talk with the owner. It's definitely reducing the risk. And now I'm very unhappy here after I tested these animations a couple of times that they are not working for whatever reason, which is not great. I need to apologize for this. And now even my computer is stuck. I cannot go through my slides anymore. What's doing it again? Yeah. Okay, so let me explain you the principle of the system itself. So on the left-hand side, you can see a bracket with a total station, which is obviously mounted on a segment. As you can see here, also a bad example. It's a smaller tunnel, maybe a 3.5 meter ID, 3 meter, bad example. Never mount a bracket onto two segments, always only on one segment. That's definitely not beneficial, because you have also as you get closer, when you're closer to the machine, you have movements on these segments too, which, you know, at the end can cause an issue on the total station, can be out of level. I know the smaller machines also critical, as you see this pathway where people are walking, they can hit these total stations as well. So there's always a risk that people can bump into these brackets, not just hurting themselves, also hurting the system, because being out of level, and maybe in the worst case you have to call the surveyor in to resurvey. So that's why there on the smaller machines is also different solutions to keep the total station a little bit out of the way. But we have to work around the design of the machine. We have a little bit impact with the guidance systems when it comes to the machine design. So also with Herrenknecht, we get at an early stage the drawings, give some advice to maybe make adjustments, but also Herrenknecht has to work in the inner idea of the tunnel, basically placing all their machine utilities, all their fan lines and everything, conveyor belts in it. And as I said earlier, surveyors are usually at the bottom of the food chain. It also means we are not always the top priority for the laser window. The total station itself is for sure not enough. It's not the only part of the guidance system. Also fixed, mounted in the machine itself, there's a bracket with a laser target unit here in this case. This is now called AIM-X. If you wondered about the name for this laser, AIM-X. And this target detects a laser which is emitted by the total station here on the left-hand side. And eventually, based on this measurement of the total station to the target and the laser reading, the system itself generates a position. We know very well where this target is placed relatively to the machine. So we also go in the factory at an early stage. Before they have the commissioning in the factory, we do a survey of the machine, define the position of the laser target unit, also do a pre-test of the system normally, making sure all the communication channels are working in the guidance system itself internally, as well as to the PLC connection of the machine. And here you can see nicely what is also needed besides the bracket and a radio modem with a total station for the wireless communication. There's also some equipment on the machine itself. So we ensure there's a wireless communication and no wire necessarily needed between the machine and the trailing gear that's moving and the actual total station. In all the generation guidance systems, there was always a cable, so the crew on the machine had to always keep an eye on it, making sure they don't pull too hard, or on all the systems even happened that the machine pulled off the total station with the bracket. Yeah, so this makes definitely now things easier, having a wireless communication here, and people don't always have to look for the equipment. This is a typical screen for an operator. So I would say guidance system is a little bit like a Google Maps, but unfortunately, or not unfortunately, but GPS is not working, or the satellite navigation is not working. So that's why we need to have other solutions with total stations or gyroscopes in the tunnel. And we pre-program these guidance systems with the alignment. So we get from the contractor, the owner, the drawings. For subway tunnels, they usually refer first of all to the track. So that also means for us, first for the TBM, don't get me wrong, but we don't care about the track. We care about the bore tunnel. So that also means we need to get the offsets between the top of rail, left rail or right rail or center of the rail to the actual bore tunnel. So there's different kind of offsets for in curves because of the dynamics of the train that later goes into. And this all gets programmed into the system besides other machine parameters, so that the operator can see on the screen what the position of the machine is relatively to the alignment. So this is a relative position. The operator itself, he doesn't care about my easting, northing, or elevation, right? He really needs to care about how the axis of the machine, the center of the machine, is positioned relatively to my alignment, which is the board tunnel axis. In the background, for sure, everything is working with global coordinates, so that we can also do a quick export at any time and tell you exactly at what northing, easting elevation the machine is currently located. But for the operator, this is really break it down to the only most important information, which is here the deviations, we call them. Positive deviation means the machine is to the right of the alignment, negative means to the left of the alignment, as well as how the axis of the machine is positioned to the alignment, what kind of angle. We call these tendencies. So if you have a positive tendency, then the machine is further looking to the right of the alignment. If you have a negative tendency, then it's more pointing to the left of the alignment. Same for vertical. Also vertical tendency. A positive tendency means the machine is looking further up, and negative tendency means it's looking further down. Other information can be a roll of the machine. So on some EPB machines, you see also, because of the torque, you turn the color head to the right, machine turns to the left. Operator sees also, the roll is increasing. At some point, you might need to turn the cutter head in the opposite direction again to unroll the machine. So also roll of the machine can be critical when it comes to the ring build later on, because of the roll, all of a sudden your jacking shoes are also rotating, and on some designs it can be critical because of the joints, and you don't want to have your jacking shoes sitting on your joints. Different kind of machine types are also visualized here. That's what we need to take in consideration. I mean, the most simple machine is a single shield machine with a tail shield welded to the machine. But obviously there are articulated machines which have either a front shield which is articulated in order to deal with tighter curves, or a tail shield can be articulated. There's double shield machines, not so many in Canada at the moment. But the double shield machines allow ring build and mining at the same time, which is also another challenge for a guidance system too, right? Because you need to ensure that you have always a position on the screen, but also allow the ring build at the same time. And then the gripper machine, the next gripper machine with a VMT system will be Eagle Mountain in Squamish, British Columbia. So this is where we will gonna have a similar visualization like this one here. Gripper or main beam machine called. Nice information, geology can be also put in. So based on the drawings we get, we can even put into a guidance system for an operator information from the boreholes and say, okay, from this station, you will have most likely this kind of geology. We can put called areas of interest in. So if you have critical areas along the alignment or like a safe haven, we can put this in as an information. So the operator even gets an information from the station of the cutter head to the beginning of the safe haven. You have 55 meters left to mine. It's just an additional layer of information, right? So you can automate this a little bit instead of people looking on a spreadsheet or something that's printed out, hanging control cap, and always looking back and forth. How much do we have left until we are supposed to hit the shaft, for example? You can see this on the screen. But it also means, again, the information that go into the system need to be correct, right? If the data are not right that go in the system would be also wrong. Information also for the operators here, they can see if a total station is still level. So if somebody bumps into a total station, the system can also give a warning that's out of level, or you can see that the actual bubble is not right in the center of this crosshair. Gyroscopic system, that's a non-optical system. I don't need to go much in detail. Screen looks very similar eventually for operator, just a few minor changes in terms of status information, but overall same approach. Here's some text. I'm also happy to share this as a PDF later. Don't need to go into details here. And most of it I've explained. We as VMT are also looking how we can support the operator more in terms of steering. So we have also developed a solution. Let me go back here. I don't have this on the screen right now, but when it comes to steering into a curve, we can also display in our system a proposed steering value. We have seen this also a lot being a problem for operators, not really knowing how much steering difference is actually needed between the cylinders, left and right side, for example, in order to get around for example, a 200-meter curve. And so the system can at least give the operator a little bit more an idea of how much steering is actually needed, instead of him going step by step and closer and trying to see when the machine really reacts to the steering. So this is also helpful. So the guidance system is more just than a display of a machine position. It's also, let's say, how to get an aid. So a system that also assists, an assistant system. That's what I want to say, an assistant for the operator. To make things easier for the crew on the machine, especially here, either the shift engineers, because we need to see who is actually dealing with the guidance system on the machine the most. For sure, the operator who's on the control cab and is the final user of the TBM position is one person, but interacting with the system, we have either the younger engineers, shift engineers working with it, also older shift engineers, not all of them are young, interacting with the system, and for sure the surveyors. To simplify the use of the system a little bit, and instead of going back and forth between a control cab and where the total station, for example, is located, the people on the machine have the opportunity to also use an app. So you can install a VMT app on your phone, and you can control the guidance system through the app. So this is nothing that goes through the internet. The VMT system has its own Wi-Fi on the machine, so you're not relying on a internet connection on your job site in this case. For sure, internet connection is needed for remote support. So if you want to call us, you have a problem, it's always good you have the internet on site working. Then we can quickly log in. I can log in from my cell phone with for sure a different app for remote support. But this makes things definitely easier. But for you as an engineer on site, the app allows you to control the total station. You can relocate the total station. Relocating means moving it into a new position because you're getting close in the curve to lose line of sight between the laser target and the actual total station. This app makes it easier. I remember 10 years ago, people had to go either back and forth between where the total station was located and the control cab where the operator is with the guidance system PC, which is time consuming. And then if you have a problem, then it makes it even worse. And not all the total stations with the laser windows are always nicely located where the control cab is. If you have gotten around the machine, you know it's not always a straight A to B. Sometimes you have to make your way through the machines, and not always easy. And also these laser windows are sometimes not easily accessible. Yeah, here another example. Here's actually a different system I will mention later, where the total station is not mounted on a precast segment anymore. That makes everybody more happy, less drilling needed, no handling of heavy brackets. And here this person using a tablet, so the app runs on iOS or Android, and you can use a tablet, connect to the VMT Wi-Fi on the machine, and you are able to control this. And for sure it's secured, so it's not like everybody can just download the app and can start using it. So that's clear. That's what it looks like, different options. Also for the ring build, you can even initiate your ring build in the VMT software with the keystone position selection in this app as well. And if you have more than one TBM on your project, let's say we have a surveyor working on the Eglinton project in Toronto, 2 machines, he can have both machines in his app, but it also means he needs to be either on the one machine or on the other one. So it's not like he can, with this app, take over the system on the machine that's next door. This is a newer development from our side. I actually presented this also during TAC last year. It's the moving station. So that's a system that gets more and more traction on these jobs at the moment because of the usability and how the system is actually set up. So this system allows us now to mount a total station in a fixed position on the trailing gear, while before we had the total station always sitting on a bracket mounted on the tunnel wall. You drill these brackets. These are usually heavy, sturdy brackets because you want to make sure they are not moving. And now with this solution, you can actually have this total station in a permanent location on the trailing gear. So that means also this line of sight is always more or less constant, right? Because when the machine is moving, this total station is moving as well. While you need for sure still prisms mounted on the tunnel wall, but these prisms are now, yes, they're not that big. Some job sites even glue them. I'm not a big fan of gluing them. There's more risk something happens to the prisms. But it's definitely a little bit an easier setup. For whatever reason, this animation is working. That makes me happy. So you can see here, before the machine is actually moving, and I stop this right now, before the machine is actually moving and the trailing gear is moving, the system performs, it's called a resection, What is a resection? The total station needs to measure at least two prisms, preferably at least 3, with known coordinates. And after this process is completed, we get an actual position for the total station, where it's located, and then the total station can measure to the target in the machine. And this process only happens when the machine is not moving. When the machine is moving, the total station is actually in idle mode, it's not being used. So we do this again. So we do the free stationing. After the free, doesn't like my click to stop the video, right? After the free stationing is completed, the total station will not stop now. Might talk a little bit faster. Total station will measure to this target unit. We get an initial position of the machine before they start mining. And once they start mining and tunneling, these thrust cylinders are extending, and we're using different sensors from the machine to continue calculating the machine position. Once the mining has been completed, we can update the position again, and this is how it goes. And at some point, as you can see, you go around the curve, you might lose line of sight to one of these prisms. You need to relocate the prism when the machine is not moving, generate a new coordinate for this prism through the guidance system itself. And so basically it's leapfrogging these prisms as the machine is moving forward. But as I mentioned earlier, it's not like you can just leapfrog and continue mining until the end. You also need to perform regular survey checks. That's just needed. Even if the guidance system tells you you're right on line and grade, it does not mean you're on line and grade. It's not like you shouldn't lose the trust in the system, but it still needs to rely on the surveyors and the work they do and the coordinates they put in the system, that the system is actually absolutely reliable and not like internally reliable without having the absolute accuracy. Here's an example how prism is being glued and attached to the segment. And here you can see, obviously, there's no bracket mounted on the segment anymore. This is in a fixed position. Project in the UK was taking one of the early projects where we used the system. The benefit here is there's less risk that people maybe bump into a bracket or the machine can hit it, right? Because it's always in a fixed position. Everybody knows where the total station is, and the total station doesn't change relatively to the machine's position as the machine is progressing. Here's some other example on a smaller machine too on the right-hand side, where we're in a start situation. Also using this system with having the total station mounted on the trailing gear can also simplify the setup for the job site, because now you might not need a big, huge bracket for a startup situation in a station or in a shaft where you need to come up with a lot of steel that needs to be welded together to have a proper startup bracket. So you also get a little bit more flexibility in the system with this system, and also reduces for sure costs in terms of the additional material that you need. In the system itself, you always have the option to switch between two modes. There's the standard mode. Standard mode is having the total station on a fixed bracket, or switching to the moving station mode. Moving station means the total station is traveling with the trailing gear. And in the system itself, we have also the option for these, you remember these measurements that the total station is taking to the prisms. They can be manually triggered, or they can be automatically triggered. But they can only be started when the machine is not moving. So the guidance system knows the status of the machine based on the advance, we call it the advance bit, for example, or the ring build bit. This triggers automatic measurements. As soon as the machine is moving, you cannot utilize the total station because you cannot even do a proper resection. So this is the whole process, just in a few screenshots here. TBM position determination. This is the end of the process where the total station first does the resection, eventually shoots to the laser target in the machine, then we generate a position. And then, as you remember, when as soon as the machine starts mining, total station is in idle mode, and the system continues calculating in real time a machine position based on roll and pitch that comes from an inclinometer, as well as extensions of the cylinders of the machine. And AI is always, or machine learning is always a hot topic. also for us in tunneling. And the guidance system actually also learns how the machine is behaving in the ground based on these total station measurements, and compares the data so that we actually predict the position based on sensor values. There's additional information about the benefits of the system, which I've already mentioned. There's other solutions for other machines, for example, the double shield, and I want to mention this, even you won't see it that much in North America, because the double shield machine also needs the right ground conditions. So in a soft ground, you're not having a double shield machine. But what's really important is that we're also utilizing other type of sensors. We're using cameras as well with special pass or with markers. They're not like a QR or barcode, but they allow us to also position or calculate the position of a machine. So we are still having a total station here and a target unit for the rear part of the machine. But since we have a main shield and a front shield, and the front shield is moving totally independent from the rear shield, because we have main auxiliary thrust cylinders and we have main thrust cylinders and auxiliary ones, we need to find a way how we also calculate the front of the machine. And so this is an optical system which utilizes now these markers, and based on how these markers are moving relatively to these cameras, so these cameras have a really high resolution, we actually calculate the position of the machine. I think that's a pretty cool development, instead of just only using lasers and total stations. And the theory that's behind this system is now also used on the tunnel formwork system. So we have recently also entered with our guidance system solution the tunnel formwork market. Tunnel formwork also needs to be positioned when it goes to the secondary lining, and also in these projects, it's important that you put the formwork in the right position relatively to the alignment. Normally, this is a manual process where a surveyor has to do several iterations between the operator for the formwork, moving the formwork, and getting it in the right place, communicating with the surveyor, which we will now have more or less have a semi-automatic solution. So if you have any interest on this, I'm happy to share some information with you later. But if you have a project, it can be secondary lining, can be even for a station where they need to have a tunnel formwork. This can be used there as well. And we did Thames Tideway in UK, where they actually did a 360 lining with a formwork of an existing segmental line tunnel. This was the first project where we used it, and now we're using it on other projects, either for stations or for tunnels that were conventionally built, and then later a tunnel formwork goes in there for the final lining. I don't need to go too much into detail for the system. Also, the tool is Pulse. That's a backup system, so we also have backup features in there in case something fails on the system and the total station is not communicating anymore, or there's a problem on the target unit, or we're losing line of sight. So there's at least backup features still to continue mining and ensuring that you can still have a position while maybe the crew is trying to figure out how to get the spare part on the machine, because eventually, based on the contracts and how the specs are written, we also have to ensure that the guidance system is running while we are tunneling. So we have to accommodate for this. A little bit more information about the equipment. I've already told you about it. Really, since we have this wireless communication and also utilizing a Wi-Fi signal, not another kind of radio frequency, taking the benefit with the app was definitely also a game changer for not just as VMT and our engineers, also for the job sites. So they really appreciate these functionalities. But I also have to mention, if we still do tunneling with total stations in 10 years, it's also questionable. The technologies or the sensors are improving, so that we might even not see a guidance system with total stations in the future. There might be other options. And I have to admit, we're also working on some right now. We still have time. I don't know, Graham, if you can say something. We have 5 minutes. I know the focus was more on guidance, but placing the machine in the right position is one, but also placing the precast segments in the right position behind the machine is even more important, because that's the final product most of the time, unless we have another type of lining. So that's why I would say we definitely jump into this too.
Yeah, no problem, Matthias. Keep on going.
Okay, sounds good. Okay, great. Also, this is not working for whatever reason. Now you can say I was badly prepared. I can only say I did all the commissioning and testing in the factory, literally, and now on the job site it's not working, and I have no explanation why it's not working, because I went through all this. Anyway, the idea of the ring sequencing and the software is utilizing the data from the machine in terms of what is my position of the machine relatively to the alignment, how is the machine steering, what are the extensions of the thrust cylinders, in order to calculate the correct position of a ring that's being built behind the machine. So each project has a specific ring design. When I say a specific ring design, it's not just the diameter or it's the concrete. I'm talking first of all only about geometry, which is important for me, more important first of all. So they have a different taper. So the taper defines the feasible radius you can do with your ring design. A little bit a rule of thumb for you I also like to give you is, let's say your design or your alignment requires a curve of 300 meters. Put enough safety factor in there, what your ring design can actually do, so that you can also compensate for going offline. I usually recommend, as a rule of thumb, maybe a factor square root 2. So for example, if you can do, if you need to do 300 meters, then you divide the 300 meters by 1.4, then you might end up with 210 meters that your ring design should at least do. So it's something to keep in mind. And I also see sometimes people doing mistakes when they define a minimal radius. They only look in a sequence, maybe just looking at one ring, what one ring can do when the taper, the skinniest part, is right on spring line, but your actual ring rotation might not allow it, or even your combination of rings, where you don't want cruciform joints between adjacent rings, won't even allow you to really build this tight radius. So when you do the design, or the planning for this, always put enough safety factor in it, and take this in consideration. This also eventually ends up also in a machine design when it goes to tail skin clearance, which is the gap between the extradors of a ring. So when we look here on the screen and visualize this, so this gray circle on the outside is the tail shield as a visualization. And as you can see with this A, B, C, D, E, F, these are the segments of a ring, the precast segments in this case. And we pre-program also our system with the dimensions of these segments, because that's crucial for the right ring selection, and making sure also when we have building the sequences ahead of the project, there's not, depending on the ring keystone position, not every combination is possible, because you don't want to have cruciform joints between adjacent rings. So you also look into this and exclude certain sequences to ensure that people don't build the right combination of rings. Unfortunately, it's still happening, because what's still happening is that people, make a calculation here, make decisions in the software. Doesn't necessarily mean this is what they physically built. And we also try to prevent this together with Herrenknecht, that, for example, they can only release specific thrust cylinders when they start building a ring, so that you can even avoid that they place the first segment into the wrong location. Because where you place the first segment will eventually define where the last segment ends up, and this will define your keystone position. And the keystone is obviously always the last segment that goes in before you complete the ring. Ring roll is another topic, how rings are rolled relatively to the machine or to each other. Here you can see a development of the rings, where you basically have it break it down into a flat surface, just to visualize, cruciform joints, and get an idea what the orientation of each ring is, now they sit relatively to each other. But I can tell you, it happens often that people build the keystone in a different position, even a position which might be allowed at some point, but then the system doesn't know about it. And let's say this case here. okay, we are having this. This was the last ring that was built, an L02. Whatever L02 right now means, that means a certain keystone position. L and R means we have a different design for the rings. We have left and right rings because the tapers in different position. The contractor doesn't want obviously a keystone below spring line. That's why they have left and right rings. I mean, now we see a lot of universal rings, and people are not really concerned about keystone below spring line. Mostly safety reasons, right? Or also the assembly of the ring. You can imagine when the machines were maybe less sophisticated, it was more critical also to wedge the keystone into the invert because of gravity and everything. So that's why there was a lot of also safety reason. You know, you have the heavy segments on top, and it's a small segment in the bottom, which is the keystone. There was also concern. So that's why left and right ring design was always quite dominant especially in the subway projects, but I see it's more and more projects where they can just put the keystone around the clock. So people, I would say, don't get more adventurous. They have just more trust in the systems and the machines and in their safety. But in this example, let's say the system has been calculated and stored in L02 position, but physically, for example, they have built an L03 for whatever reason, and the system doesn't know about it. And now the system, when it calculates after the next push, the next ring, still uses this L02 as a reference and proposes a ring which is actually not compatible in terms of the cruciform joints with the L03, which was physically built. So that's why also the people need to use a little bit their brains on the machines and cross-check if what's in the system was actually really built by the people on the machine. As I said, we try to prevent this with certain functionalities, but not all jobs have these functionalities yet. We will do better also on our end, but it's also up to the user that they follow what the system was proposing and not doing something different. And sometimes it can be just a bad communication between the operator's cap and the ring builder. Somebody's yelling L02 and the ring builder understands L04 or whatever. And then nobody's checking this again. A crucial value also for the ring build and the ring sequencing is the tail skin clearance. As I mentioned earlier, that's a gap between the extradose, the outside of a precast segment, that sits inside the tail shield and the actual tail shield. Because what you don't want is a physical contact at any time between your tail shield and your segment. I mean, it will happen, especially in curves, vertical and horizontal curves, tight turns. But the preferred option is for sure if you can always nicely place your ring perfectly centered in a tail shield, so that you have always a nice gap on each end. So in the ring selection process and the ring building process, you need to measure these gaps before every ring build, and this can be manually done. Or can be automatically done. So there's system solutions who can either measure this mechanically automated or with ultrasonic. So there are sensors on the machine, they can measure the gap, so people don't necessarily need to take a ruler or tape. So when you see about the ruler solution, the bigger the machine gets, the more difficult it gets to take these measurements, go around on the erector and take the measurements. You need to take this in 4 locations, 12, 3, 6 o'clock and 9 o'clock position when you look in direction of tunneling. So this can be also automated. When people do the manual measurement, as I said, eventually you only care about the extradose and the tail shield. To read this number here on the outside will be really hard. So that's why you can also do the measurement to the intradose, to the inside of the segment. As long as you're consistent on all 4 locations with your measurements, that's fine. But don't do one extradose measurement and then one intradose measurement, which are basically off by the thickness of the rings. This would mess up the calculation. That's not correct. So the system wouldn't even not accept these values. But if you go in the manual mode, traditional mode, people need to write down these 4 numbers, need to communicate with the control gap, need to give it back to the people, which is obviously can be automated too by having these sensors placed. So there's an example of a ultrasonic system. I have to admit that the system was having issues, especially in the invert, because there was mud, water, sometimes even the grout on top. So you need to keep this clean, otherwise you get false measurement or no measurement, and then the system would certainly fail. So that's why we went the next step and had at least a mechanical solution, which is called Slum Touch. I don't explain why it's called SLUM, because with a lot of German companies, that obviously has a German background, the name, so it would be too hard to pronounce it most likely. So that's why I can pronounce it, but I just want to explain it. So this is working with compressed air here, and for sure there's there's a cable for the data, so that we measure, let's say, the actual angle this arm is moving when it touches the segment. So the segment actually sits on top of this sensor here, and when you initiate the measurement, then it increases the pressure on the hose line, and this will move this arm, and then we get the readings. And as soon as the reading has been taken, then they release the pressure again, the arm gets back in its parking position. But with every piece of equipment, if you don't maintain it, it might stop working, right? So if you leave the grout on it and the grout gets hard, then it will stop working. So it's not like this can break free by itself. So you also need to have a crew who is looking after the equipment. And this includes also equipment that's related to the guidance system. I've seen it. I've received calls from people telling me the total station is not measuring to the target unit. So on top of the target unit, you may remember the box that I showed you earlier. There's a peanut prism mounted, and the total station is measuring to this prism. The people are saying total station is not finding the target. So, and what happened eventually? What was the cause? People didn't clean this little peanut prism. So a really minor thing shut down, stopped the machine. In this case was several years ago, probably for an hour, because they called me after an hour, they couldn't figure it out. So this is sometimes just common sense that people need to use when it comes to the problems. And maintenance, preventive maintenance, can really prevent these kind of issues. Yeah, this is the automatic system measuring the data and automatically transferring in here. As you can see, this is in looking direction of tunneling. We usually use 5 sensors. Normally don't put one right into the invert, but because that's where all the material accumulates and piles up. So you try to break free a little bit from this area. So that's why we usually put them, let's say, in the 4 or 5 o'clock and in the 7, 8 o'clock position. Graham, should we also have a little bit of time about questions? People might have questions too.
Yes, I believe so. Unfortunately, our Q&A function seems to be a little bit on the fritz,
okay,
as it were. So I'm going to say continue on with the rest of your presentation, keeping in mind some people might be leaving their lunch break now or going into other meetings. But if anyone has questions on their mind, they can please send them to TAC-youngmembers, YM, at tunnelcanada.ca in the meantime, or even reach out to me on LinkedIn during the last couple of minutes of this presentation if you have a question that we'll try and get answered. Otherwise, we can answer them at a later date. But I'll let you finish there, Mathias.
Yeah. Okay. And I'm also happy. Reach out to me if you have specific issues on upcoming or existing projects, and you're looking for ideas, advice, or want to give me ideas for future developments. I'm happy to talk to you. And everything that's coming now is a little bit just an extra. So it's not like this was planned, but I'm just in a talking mood now. So and obviously we are not having a direct conversation between the attendees and myself. I wasn't aware of this, so I thought I was a little bit more a personal level of interaction, but that's fine. No problem. So when we also come to the ring build, and after the ring has been built, it's also quite crucial, and we also see this a lot, that people have demand on what's the actual shape of the ring after the ring was built, and is it moving? Is it being stable? And for this, there's obviously the possibility you can send a surveyor in, and the surveyor can try to make measurements and tell you if the ring is round or not, or if it has moved or not. But as you can see, and as we know, it's quite crowded in the tunnel down there, right behind the machine, all the installations, trailing gears and so on, so that eventually there's no line of sight possibilities for a surveyor going into the total station and doing measurements. So for this, there is automated solution, which is called RCMS, the Ring Convergence Measurement System, which allows you now to monitor the movement on the rings in more or less real time. So as the machine is progressing and moving forward, these sensors are giving live data. So it's wireless installation, giving live data to the operator screen or to the engineer screen, which eventually allows them to see directly, you know, what is happening there, or even you can see if the grout, when you grout the segments, if there's any movement. These systems are not only used just purely right after the ring was built. You can also place them, for example, when you would do cross passages and you do the cutout for the cross passage on a subway tunnel. You need to monitor the rings that are adjacent to the cross passage or the segments that are right in the cross passage area. You can for sure always have a surveyor there and doing it, or you're thinking about A, you don't have enough people, and B, you need the data faster while you're doing your cross passage excavation or the cutout. Then you can have an automated system, taking away the need for a manual survey, and then even having maybe somebody who still needs to process the data, somebody maybe who has to go out of the tunnel first to get the results, right? I guess nowadays with technologies and sensors, we're all used to having instant information and getting them directly on a PC, on a website, in a cloud, or on a mobile device. That's the same here too. And here's just examples how these sensors are mounted. There's different types in terms of the size. Why different types? There's the bigger one on the left-hand side. They are easier to maintain in terms you can change the battery, the internal battery, so they're all battery powered. These smaller ones, they have like the size of a baseball, which makes it also easy to install. They can be glued, or they can be we can use bolts and attach them to the segments, so they can be also easily removed again. With the older systems, there was still wires, which was always a little bit complicated to set them up. So I think the best time on a 10-meter machine, it took me 1 hour. With the old system to set it up, with this one, it might take you, let's say, 20 minutes, and you have it running. Now here, some job sites got a little bit more creative. They put these sensors actually in the pocket. Here where the cone goes from the erector, lifting devices. So that's definitely also a nice option. You have less exposure, easier installation, no drilling at all needed. And this is what you see in the data. Here's the data coming out of these sensors. So obviously we are showing convergences which are metric values in terms of distances, but these sensors are inclinometers, which give us only angles. So based on the geometry of the ring, and the position of the sensors, we can eventually derive the actual distances from it. And here you can see how these convergent distances are changing as the machine is progressing. So on the bottom, you can see the distance of the front of the machine relatively to this cross section where you mounted your sensors. Because in the system we assign ring number 202 has one set of these sensors, and we know the location exactly, the station of the ring, so we know where this ring sits relatively to the front of the machine. And you can see as the machine is progressing, moving forward, as further machine goes away, you get more stable data in here. And you're not getting this kind of dense information from a regular surveyor, because the surveyor won't be able to give you this information where the machine is mining, for example. Then the accuracy we say about ±1 millimeter. Typical intervals for this, it can be changed. So you can have 5 minutes, you can have 1 minute. It's not necessarily needed to measure in 5 seconds interval. And for sure for the end user, for the engineers, you have a PC in your office, you can create a report for your own purposes, give it to the owner, so you can tell them exactly about the monitoring and the results. Okay, that's all about TBM tunneling for now. So we are at
Perfect.
Now 1:15. So if there's need one time for other kinds of tunneling methods or data systems, or if there's need for tech to hear a little bit more about very precise measurements for the precast segments and the quality control for the precast segments, the handling in a system, I'm happy to give another talk or presentation in the webinar, or we meet at the Lone Star Grill one day. This will be in person. There will
Perfect.
be
I
more
know our
interaction, I'm
attendees.
pretty sure.
Yeah,
Yeah.
again, of course. I think despite the fact, again, apologies for the Q&A function not working, but if you have burning questions, again, you can please forward them to tac-ym at tunnelcanada.ca. And in this way, we can forward the questions along to Matthias and get the questions back to you, or answers back to you. While our attendees are still in here, though, I think we can still have a little bit of a conversation in the next 5 minutes or so. I'd say, Matthias, there's a lot of information there, a lot of really great information. For the people who maybe don't have as much experience on tunnel boring machines and site experience, what are the three main or couple main details when you're curving a tunnel that need to work together? For example, how do ring selection, surveying, and even like the TBM operator all kind of mix together to successfully curve a tunnel on the alignment? And do you curve a tunnel quickly, or how do you plan a curve?
Yeah, I mean, let's say we're not necessarily planning the curve. Everything starts on a piece of paper, first of all, right? So we have an owner with a project, and there's a requirement either to bring people from A to B in an urban area, or bring water or sewage from A to B in an area. So, and then you plan your route. And for sure, when it comes to the route planning, the designer should also look in the capabilities of the equipment. Sometimes I see some approaching certain projects a little bit adventurous, especially in the microtunneling world, trying to push boundaries in terms of distances and tight diameters, and accessing the tunnel eventually. Because at the end, you need to see in a microtunnel, for example, you have people who still need to go in there and do the work. Not necessarily being in the tunnel all the time, but the surveyor still has to go in there. And if you have a 1200 millimeter ID and you go for like 600, 700 meters, it's definitely not in a nice environment. Maybe sometimes you need to think about increasing diameters. But yeah, this is one thing. Seeing what can the technology can do, what can the people can do when you design this. We also know that, you know, the TBM manufacturers in the bigger tunnel segmental lining, they can also achieve sub 200 meter curves, 100 meter curves. I mean, in Thailand they did about 90 meter curves. That also means for you as a designer of the precast segments, you might not even consider only having one type of ring geometry in terms of taper and ring lengths. You usually also introduce for these areas with the tight curves rings with a shorter length. So the project here in Seattle, the Seattle Ship Canal, they had some quite tight curves, which were also, I think, 195 meters. And instead of using the 1.5 meter, which is, let's say, a standard length, they were going with 1.2 meters for the short curves. So that you had like different molds, but somehow you need to ensure, right?
Interesting.
And that's something to keep in mind too. So that at the end you have a segment yard with segments which are different. So you have a stack, and one stack might have the shorter one have the longer ones. But it also means the guidance system is pre-programmed and knows in advance in what areas it should select one of these shorter segments and one of the longer segments. And also the guys on the machine need to know ahead of time from the guidance system, so they can already pre-order these segments. If you're 5 kilometers in, you don't want to order your segments when you're actually ready to build a segment. You want to order it before you're starting, maybe 2 pushes before, because it's going to take time to load, bring it in. I mean, there's California switches, trains can go by, but it's also the logistics behind the machine we need to keep in mind. For the surveyors, the more curves, it's definitely also more challenging. The more curves means also there's more surveying effort needed. It also means for the guidance system, you need to relocate the total station more, or with the moving station, you need to have shorter distances between these prisms. It also means the surveyor needs to more frequently update the guidance system. So a long straight run is for sure, and in a big diameter is the easy part. So this can be the entry level for everyone, and then you get a little more challenging. Either you make the tunnel smaller, or you come and increase the amount of curves.
Interesting. Perfect. And one last question. I think anyone who's in a supplier capacity, or especially the amount of, it sounds like there are a lot of innovations that you were talking about that are happening within the company, but also within the industry. What is your prediction in the next 5 years, or what are you most excited to see develop within guidance technology within underground spaces for conventional mining or TBMs, whatever is on your mind that has really got you excited lately?
What really gets me excited is the automation. It's the interaction between different companies working together, improving a workflow, trying to have a direct link between different systems, and analyzing the resulting data instantly, and making sure that these machines are working properly, most efficiently, and for sure in a safely manner. So this makes me really excited, without going really in specific details for certain sensors, but definitely having automation for surveying too, as-built surveying in the tunnels. It's not like us taking away the work from people, because there might not be the people still there who can do the work. So we are facing this, and we're not just facing this in the surveying world, we're also facing this with other reasons. We will see also more that there will be at some point less people on the machines needed. That's clear too, right? And sometimes even we are not that far everywhere yet, not necessarily because the technology can't do it, it's because the people are not willing to do it yet, or not willing to do the risk, take the risk. But as I see also more younger generations, we're coming back to the young members too, getting also more into the positions where they can make decisions. This also opens definitely a new field for technologies, in my opinion. Perfect. So there's a generation change and a technology change, more or less in the same time, which also hopefully helps us to introduce different solutions in the tunneling here. But it needs always both sides. And I know we are not perfect with all the solutions we have. We also see a lot of issues and problems that are happening on job site. So that's why I'm also always happy for input from everyone that we can get, also to develop new ideas. But at the end, yeah, we try to make the tunneling more efficient, together with the machine manufacturers and other people who provide their equipment for the job sites.
Awesome. Yeah, it's exciting. I know as a recent university graduate, time flies. 4 years ago, I know that as young members and in engineering school in particular, one of the most trendy things is automation and software engineering, and everyone thinks about the applications of this in cars that drive themselves, or apps that can regulate your home temperature on their own, but no one thinks about, the critical infrastructure that we need to survive in terms of clean water and dealing with sewage and public transportation, that these areas of industry can have these technologies applied to them as well. It's not just reserved for Facebook and Tesla. People are trying to use this automation and machine learning within tunneling, and something that's maybe thought of as a low technology industry compared to other career options. So it's exciting to hear like the front line how this stuff is being implemented on real projects happening today. For all of those of you still listening, if any of you are university students, speaking of which, we'd like to remind you that scholarship applications are still open and closing on March 15th for both the undergrad scholarships and graduate level scholarships. And more info about those can be found on the TAC website under the Young Members Awards subpage. and the application package and how to apply instructions are on there. So thank you all very much for your attention. Once again, apologies that the Q&A function is not currently working, but we really appreciate your time. And Mathias, thank you for giving up your time to present and educate everyone on what's going on in the tunneling world and how we're steering our TBMs. Really appreciate it, and I learned a few things, even though I work with VMT things all day. And it's always good to chat with you, and really appreciate the time.
I work with VMT on a really regular basis, and I always learn something new too. So we're always learning. I think we're not just learning because we're going to school. We are learning when we are out there, when we are exposing ourselves to the environment, and that's the best way to learn. I mean, you really lay the basics in the school, but really go out there, expose yourself in terms of getting also your hands on, talk to the people, learn from them, see where the problems are. See how problems are being solved, develop your own ideas, apply them, share with others. I think that's also really important in our industry, that people share with each other. We not always should share the success. We should also share when we had problems, so that people not having the same problems again. I know there's for sure we all have secrets for certain reasons, but I don't think the secret should be that we keep other people's will fail again, because we want to make sure that our industry is well accepted, that owners are willing to build more tunnels, and not hearing from a project that a machine got stuck because of something, and now they're not approaching the projects anymore the same way. That's how I see it, and tunneling is really an exciting environment. It's for sure not the cleanest environment. That's clear. It's noisy, it's dirty, it's dangerous. Always keep in mind safety first with everything we do. Yeah, and don't always just listen what other people say. If you don't feel safe, don't do it. Talk to somebody. We all have been there where people think, oh yeah, that's safe, you can do it. We did it always this way. It's not what we did this way is the right answer. So if there's another way to do it in a more safer way, then that's the way to go.
Perfect.
Yeah. Otherwise, everybody who's entering the career, I wish you all the best. Maybe one day we're going to see each other. Either you are on the owner side, the contractor side, you're making decisions on automated solutions. Keep always in mind, keep some budget for the surveyors as well. Otherwise, thank you for the great opportunity to talk to you and share some of this. There's a lot of more stuff we can talk about. I mean, we don't need to take a deep dive. It's a big variety, but I hope I gave you a pretty good overview about what we do with these TBMs, making sure they go from A to B with very accurate. And always think a few millimeters versus a 15-meter diameter TBM. That's quite good, and it takes a lot of effort.
Perfect. I like that. I like leaving on that. Remember to leave money in your budget for the surveyors when you're running projects one day. Perfect. Yeah. And with that, we'll end the live, and thanks everyone for coming.
All right.
Cheers. Thank you.
Thank you so much. Have a great day and stay safe.